A group of senior engineering students from Cleveland State University recently competed in the NFPA Fluid Power Vehicle Challenge in Colorado, April 11th and 12th. The team built a hydraulic-powered bike for their senior design class project. The tricycle, capable of reaching speeds of up to 40 miles per hour on hydraulic power alone, captured top prizes at the event. Engineering students in senior design undertake projects to utilize the skills they learn in the engineering program.
After you're assigned a project, you kind of just hash out what are the design objectives, what are the goals, and go through the whole engineering process to come up with this end goal. At least for our project, this was our end goal, and we accomplished that.
The group, consisting of Jen Wisniewski, Sean Mulvin, Matt Sikolich, Marcus Coetzee, Patrick McDonough, and Jason Downey, received help from advisors and sponsors along the way.
Well, actually, we had a bunch of people really help us. I mean, Bogdan, for one, he was a really great resource to get our questions answered, to come here for the lab and be able to use. I know the quick disconnect testing that you guys did, that was all done and available to us because of Bogdan and the Fluid Power Lab here. We had contacts with a couple of different Parker people. Our industry sponsor was Nathan Settlemeyer, who Marcus talked back and forth a lot with. He came here 3 times to the school. He looked at our bike design. He helped give us some recommendations how to improve our design. He also helped get us some extra materials from Parker that we could use for the bike.
In Colorado, competing against teams from 14 other schools including Purdue University, Murray State University, the University of Denver, and Iowa State University, the team won Best Design, Best Presentation, and the Sprint race while placing second in the Endurance and Efficiency races. Their effort was good for first place in the overall competition.
What were some of the things that set your bike apart from the other bikes that were at the competition?
Absolutely simplicity. Simplicity was seriously the thing that won us. Some of the other bikes, granted, they were more technically advanced in certain ways, but it was just more modes of failure in that sense. And in the end, we won.
Awesome.
One of the bigger things that helped us out is that we did a lot of testing. Some teams, due to different reasons, weren't able to get a whole lot of data. And pretty much most of the semester, we've been trying to get as much data and running the bike to figure out who's the best rider, what are the best settings to try to best win the races.
Throughout the process, the group encountered problems that had to be dealt with for the machine to work at the highest possible level.
One of the big things our challenges that we faced before the sprint race was, 10 minutes before, there was a aluminum shaving about this long deep into our tires, so we had a flat tire. Luckily, Marcus packed a bunch of extra tubings for the tire, and we had to really quickly change out the tires and be ready for the race. So that was one of the big challenges that we faced.
Another unexpected problem came when the rules of the competition were changed to disallow the team's innovative charging technique. This used a drill to turn the pump rather than pushing the bike around. This technique allowed the team to test their bike more often than the other teams in the lead up to the event, something they said was key to their victory.
The challenges and successes that the team experienced throughout the project not only helped them in the competition, but taught them a lot about engineering.
I found that this project shed some light on more of a project management standpoint of things. It was a little difficult to get everyone hands-on, but once we kind of got the pace of our group and the camaraderie, essentially, things just kind of started falling together. That's what I found was the most beneficial. I don't know about you guys.
Yeah, it was good because we had different groups or vessels, if you will, like different teams to do different tasks. So everyone kind of had their own task that they were in charge of, but you were able to delegate and have other people help you out with your task, and you would help other people with theirs. So you might be the project lead of fabrication or calculations, but you had other people to help you, and you helped them on their aspects too. So it was not just being the leader and delegating and working on your own project, but it's helping out everywhere else. So it was a really big advantage for us.
Overall, the group was able to come together and utilize their skills to create a machine that tested very well against the competition, fulfilling the goals of the senior design class.